Electroencephalography (EEG). Signals serve as pivotal tools in diverse medical and research domains, facilitating applications in clinical neurology and diagnosis, brain-computer interface (BCIs), and cognitive neuroscience. The conventional EEG scalp electrode measurements bulkiness and obtrusiveness restrict current EEG applications mainly to laboratory experiments. EEG headbands and Ear-EEG acquisition devices come as a solution for this. Our primary objective is to develop a novel Ear-EEG platform comprising dry contact electrodes based on rapid prototyping technology along with a signal acquisition circuitry for signal pre-processing. The target system's architecture includes a 3D printed electrode with an ear and a low noise signal acquisition circuit comprising an active shielding analog front end and a microcontroller unit. Let's look at the 3D printed EEG electrode part first. For 3D printing the electrode, Electrodes, the most conductive filament in the world manufactured by MULTI 3D, was utilized. The earpiece was printed using NinjaFlex, a flexible filament from NinjaTech. To determine electrode shape and diameters and characterize the electrified filament, large electrodes were printed and subjected to ECG signal acquisition. An analysis of acquired signals in both time and frequency domains revealed that a diameter of 2.75 is a suitable initial choice for EEG electrodes. To develop the EEG electrode with earpiece first, we scanned the ear of the participants and generated a 3D model of the ear mold. We modified that can designed by making holes to place the electrodes that will contact the surface of the ear. 3 electrodes will contact the inner ear and 1 will contact the concha region of the ear. After prototyping the ear mold and electrodes separately, we connected them with coaxial cables for each electrode. To validate the Ear-EEG electrode, we performed the alpha attenuation test by performing the eyes open and closing alternatively. Now let's talk about the signal acquisition circuitry. The acquisition circuit comprises essential components, including an active shielding unit with high input impedance, an EEG analog front end for signal amplification, ADC functionality, and amplification purposes. It is governed by an ESP32 unit serving as the primary controller, accompanied by a USB to serial converter and a USB isolator unit to effectively mitigate power and signal line interferences. Additionally, a low-noise power supply unit is incorporated to cater to the diverse power requirements of each integrated circuit. Let's talk about the results and observations of the electrode verification process.